Ambient air enters a compressor through a filtered intake which removes dust and dirt. This filter should be replaced at timely intervals to ensure the compressor is protected from unwanted contaminants. Dirty or restricted filters cause pressure drops and reduced efficiency. Filtered air continues through sealed piping to an inlet valve that controls the volume of air reaching the air end and prevents oil from reversing towards filters after shutdown. Next, air enters the air end, which is a fixed displacement pump that uses two helical rotors to compress air. As the rotor screws turn, they form a partial vacuum which sucks air into the helical rotors. The amount of air that fills the air end is measured in cubic feet or meters per minute. As air travels along the helical rotor flutes, the space storing the air gets progressively smaller. Since the air cavity between the rotors is larger at the inlet end and smaller at the discharge end, air becomes compressed, creating significant heat. During the process, oil is injected into the rotors and serves three critical purposes. 1. To lubricate the rotors, bearings, and seals. 2. Seal the space between rotors to keep pressurized air from escaping back to the inlet. And 3. Remove heat from the system so the air end can run at optimal temperatures. Using oil to maintain proper temperatures maximizes efficiency of the compression cycle. The air, now mixed with oil, exits the air end through a discharge port and is piped to a separator tank. Here, the separator will remove some of the oil from the air and let it accumulate in the pressurized tank. The tank acts as a reservoir as well as an oil service and fill point for maintenance. A sight gauge mounted on the tank's side allows an operator to quickly check the oil level.